Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns angles. This guide introduces the definition of different types of angles and the different ways of measuring them. It also gives formulas to convert between degrees and radians. Introduction. Angles are fundamental to geometry, and having an understanding of angles can help you expand the way you look at mathematics. Making the connection between geometry and the more commonly taught algebra is important and often overlooked. Much of early mathematics was concerned with shapes, and the ancient Greeks certainly knew about angles. However, the most famous Greek treatise on mathematics, Euclid's Elements, only describes one angle, a right angle, and describes all other angles as parts or multiples of a right angle. When astronomy became a more formalised pursuit, leading to the advent of trigonometry, angles naturally played an important role. Through Hipparchus and eventually Ptolemy, triangles could be solved, both plane and spherical, and the angle was firmly placed at the heart of geometry. In your studies, you will definitely come across angles in trigonometry, and they are essential to understanding the trigonometric ratios. See study guides, trigonometric ratios, sine, cosine and tangent, solving right-angled triangles, trigonometric functions, the sine rule and the cosine rule. You will also find they play a role in calculus and vectors, and so in science in general. An angle is made when two straight lines cross. The lines AB and BC are called the sides of an angle, and the point where they meet, B, is called the vertex of the angle. It is usual to draw an arc joining the two lines to depict the angle. In the diagram below, you can see a drawing of an angle. Here, A, B and C refer to the 3 points that define the angle, which is labelled by the symbol theta. You will find that it is very common to name angles using italic Greek letters such as theta, phi and gamma, and so on. There are many other different ways to denote an angle. You might commonly encounter the angle theta being described by ABC, A, B hat C, B hat, or ABC. Units used to measure angles. As in any physical quantity, there are different unit systems to measure angles. In mathematics and science, the degree and the radian are the most widely used. Many mistakes in the calculation of angles occur because your calculator may be set in the wrong mode. For example, you may have your calculator in degree mode when you need an answer in radians. You should always check your calculator is in the appropriate mode for calculation. You can consult the manual for your calculator to help you understand how to change the mode on your calculator. Most calculators have 3 modes to perform calculations involving angles, degrees, radians and gradians. A. Degrees. Symbol, a small circle. 1 degree equals 0.017 radians, which equals 1.11 gradians. In this unit system, the full rotation around a circle is divided into 360 equal parts. Each part is called a degree, from the Latin degradus, and would be written 1 degree. The origin of this system is not clear, with some assigning a link to Babylonian culture, whose year had 360 days, plus 5 bad luck days. Others suggest it is based on the base 60 numeric system, sexagesimal, as 60 is a number which can be divided into many smaller whole numbers. 1 degree can be subdivided in 60 equal parts, each named a minute, which is written 1 with a prime after it. In turn, each minute can be subdivided into 60 equal parts, each one called a second, which is written 1 with 2 primes after it. Most angles are written in decimal form, such as 47.5 degrees. However, in navigation bearings, angles are written in terms of degrees, minutes and seconds. For example, 47 degrees, 31 minutes and 13 seconds, and I said 47 degrees, 31 minutes and 13 seconds. B. Radians. Symbol, rad, or no symbol. 1 radian equals 57.3 degrees, which equals 63.66 gradians. 1 radian, or radius angle, is the angle centred on a circle whose arc is the same length as the radius of that circle. Therefore, the length of the arc of a full rotation in a circle is 2 pi radians. See table below. You may know that the circumference of a circle is 2 pi multiplied by the radius. It is very common to express radians as multiples of pi. Although the concept of measuring angles in terms of arc length has been around for a long time, the term radian was only first used by James Thomson in 1871. The use of radians as a way of measuring angles is very important when working with calculus. All calculus calculations involving a trigonometrical element are performed in radians. There are also some formulas which only work when the angle concerned is expressed in radians. For example, equations for finding the arc length and the area of a sector in a circle. In fact, the radian is the SI unit for angle. C. Gradian. Symbol, grad. 1 gradian equals 0.9 degrees, which equals 0.016 radians. A gradian is defined so that a full rotation is 400 gradians, and so a right angle is 100 gradians. They were introduced to try and decimalize the measurement of angles. This system is rarely used today, but you will find it as an option on most calculators. Classification of angles. There are different types of angles, and they can be classified according to size. These are acute, right, obtuse, straight and reflex angles, as well as a full rotation or turn. In the table on the next page you can find an example for each case and how they are defined in terms of both degrees and radians. Type of angle, acute. A figure of an acute angle looks like this. The range in degrees, an acute angle is greater than or equal to 0 degrees but less than 90 degrees. The range in radians, an acute angle is greater than or equal to 0 radians and less than pi divided by 2 radians. Type of angle, right. A right angle is depicted like this. In degrees, a right angle is 90 degrees. In radians, a right angle is pi divided by 2. Type of angle, obtuse. An obtuse angle is depicted like this. In degrees, an obtuse angle is greater than 90 degrees, but less than 180 degrees. In radians, an obtuse angle is greater than pi over 2, but less than pi. Type of angle, straight. A straight angle is depicted like this. In degrees, a straight angle is 180 degrees. In radians, a straight angle is pi. Type of angle, reflex. A reflex angle is depicted like this. In degrees, a reflex angle is greater than 180 degrees and less than 360 degrees. In radians, a reflex angle is greater than pi and less than 2 pi. Type of angle, a full rotation or turn. A full rotation is depicted like this. In degrees, a full rotation is 360 degrees. In radians, a full rotation is 2 pi. You are often required to convert an angle from degrees to radians, or from radians to degrees. You can try to remember the formulas, but it is better to understand their origin. This will allow you to derive the relationships quickly. You start by recognising that all the way around a circle can be described as either 360 degrees or 2 pi radians. This implies that the two are equal. 360 degrees equals 2 pi radians. If you divide both sides of this relationship by 360, then you get a relationship for 1 degrees. 1 degree equals pi divided by 180 radians. You can then work out a relationship for any number of degrees, say n degrees, by multiplying both sides by n. n degrees equals n multiplied by pi divided by 180 radians. Similarly, if you divide both sides of 360 degrees equals 2 pi radians by 2 pi, you get a definition for 1 radian. 180 degrees divided by pi equals 1 radian. You can then work out a relationship for any number of radians, say n radians, by multiplying both sides by n. N multiplied by 180 degrees divided by pi equals n radians. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.